Alright, so in this video we're looking at the Mathematics Higher Level Paper 2 Khomas region for August 2020 exam, and we're looking at question 10 and 11. Okay, so question 10 has us calculate the following. The diagram shows a solid cone which has a slant height of 15 centimeters as indicated in the picture and a vertical height of h centimeters. Now they'll ask us to show that the volume V of the cone is given by that formula. And they're nice, they give us the standard formula for the volume of a cone as well. Okay, so what we need, we see there's an R, there's a radius here. So what we need to do is find out what this radius is, because we don't get given that. And we don't have radius here, so we want to replace radius in terms, or write radius in terms of height. Okay, so let's see how we can do that. Well, we can do the following. Let's say we draw a vertical line here, because we know that length is h, or that height is h, and connect there. So now we've got a right-angled triangle. And we can use the Pythagorean theorem to figure out what r is. So this is r, and that is h. Okay, so let's write down the formula for Pythagorean theorem. So that would be r squared plus h squared equals 15 squared. Alright. And now we're going to get r squared by itself because we have r squared here. So r squared is just equal to 15 squared, which is 225, minus h squared. Perfect. And now we can plug that into our volume here. So volume, the standard formula for volume, is a third pi r squared times h. But now instead of r squared, we're going to put this value, right? So we're going to say that's the same as saying a third pi, and instead of r squared, we're going to put 225 minus h squared times h. And then to get it to look like that, we'll just multiply the h in here. So that's a third pi, and then 225 times h is 225h, minus an h squared times h is h cubed. Good, there we have it. Nicely done. Alright, now given that h can vary, find the maximum volume of the cone. So we know if we want to maximize or minimize anything, this is why calculus is so helpful. We can just differentiate the thing we want to maximize and then set that derivative equal to 0, because that'll give us a turning point, and the turning point is 0. The gradient of the function is 0 at its turning point. Okay, so let's just put that into practice. So we know h can vary, so we want to differentiate the volume. So let's just write down the volume formula again. So a third pi times 225h minus h cubed. Okay, and now you can do this many different ways. I'm just going to rewrite this by multiplying this in, even though that's not necessary. So a third, actually let's do it this way. 225h pi goes to the top. 225, I'm just going to write pi h over 3. So that's multiplying this in here, and multiplying a third pi with h cubed will give us minus h cubed, pi h cubed over 3. Alright, so that is the volume just rewritten, and now we want to differentiate it. So differentiating volume with respect to h, so we know here we've just got a single h, so 1 times this whole thing, so we just get 225 pi over 3 times h to the power 0, which is just 1. Okay, and here we get 3 times the, we'll take the 3 multiplied in front, so the 3 and the 3 will cancel out, and we'll just be left with pi h squared. So we subtract 1 from the exponent there. Okay, so that's the derivative, and we're going to put that equal to 0 to find the turning point, and the value for h at the turning point. Okay, so we're going to get h by itself, so let's keep 225 pi over 3 on the left, and move this to the right hand side, so that'll be positive pi h squared, and then we want to divide by pi on both sides. So if we divide by pi and we divide by pi, these pi's will cancel out, these pi's will cancel out, so we've got 225 over 3 equals h squared. And then finally we just want to get the square root. So the square root of 225 over 3, that'll be equal to our height. So that's what we want. Oh no, that's not what we're going to do here. We want to find the maximum volume. So the maximum volume will occur when h is this value. So now we want to substitute this value for h back into our volume formula. So volume equals a third pi times 225 times h, and h is the square root of 225 over 3 minus h squared. And again, h is the square root of 225 over 3, and we want h cubed. Alright, and now we can just plug this into our calculator. Okay, so let's see what happens here. So that gives us 1 over 3 times pi times, and then we've got 225 times the square root, yeah, we could probably just say times the square root of 225 over 3, and that'll be minus the square root of that. I'm just going to put this whole thing to 225, unfortunate. Okay, I'm just going to say 225 over 3 to the power of 3 over 2. Okay, so 225 over 3 raised to the power 3 over 2. Okay, and then we get that answer. So that is the maximum volume. So let me just copy that and paste it here. And then we want to round that off to 3 significant figures. So that'll be 1360. Okay, and what do we have here? We've got centimeters cubed. So we want to write down our units as well. Centimeters cubed. Perfect. Now show that the volume found in the previous question is a maximum rather than a minimum. So how can we do this? Well, the short way, and what they probably expect here, is we just find the second derivative and substitute our value for h in and see if we get a positive or negative value. So if we do, let's say we have some function. If we find the second derivative of that function and we substitute in some value at the turning point, so let's say that value was, or we're going to do h in this case. If this is less than 0, so if it's negative, we have a maximum value, and if this is positive, then we have a minimum value. So this is the idea we want to follow here. So let's see, let's find the second derivative. So we know the first derivative was 225 pi over 3, 225 pi over 3 minus pi h squared, because that was the first derivative. Now we want to find the second derivative, so we want to differentiate this thing again. So this thing differentiated will equal, any constant just becomes 0, and then this will become negative 2 pi h. Perfect, so that's the second derivative. And now we want to find what the value of the second derivative is when we substitute in the value of h. And we saw the value of h was 225 over 3. So what does that equal? Well, it's negative 2 pi times h, 225 over 3. So we see here this answer is going to be negative, right? But let's just type that in the calculator just to show. So it's negative 2 times pi times, and then we're going to have the square root of 225 over 3. So we see that's negative something. I'm just going to copy this whole thing again, copy and paste. So that's that. So that's negative, which means it's less than 0, which means this is a maximum. Okay, so that's all we need to show, that the second derivative at this value for h is less than 0 or negative. That'll give us a maximum value. Perfect, so that was question 10. And we'll do question 11 as well in this video. So when log y is plotted against x, so that means we've got a log y axis here and x axis there, a straight line graph through these points, 2.2, 3 to 6, the 2.2 and 3.6, and let's say 3.4 and 6 is formed, something like that. Okay, even though it's not necessary to picture this, I find it sometimes helpful just to picture some things here. Okay, given that y equals a times b to the power x, find the value of each of the constants a and b. So we want, since we have a log y and x axis, we want to do log of both sides and simplify that. So if we take log of both sides, that will give us log y equals log of the right hand side, which is a times b to the power x. So the left hand side we can just keep as log y. Over here we'll apply our rules. So if we've got some things multiplied together, we can say that's the sum of the logs of it. that'll be log a plus log b to the power x. And then finally, we keep the log y, we keep the log a, and now we know we can take the exponent to the front to make it a coefficient. So plus x times log b. Alright, so now let's compare this. It told us it's a straight line. So let's compare this to what a straight line would be. So this is our vertical axis, which would be a y in a straight line. This is just a constant, so that would be our c in a straight line. X, that's our vertical axis, so that'll be x in a straight line. And log b will be our gradient in a straight line, so that'll be the m. Alright, and from this straight line here, we can find the value of m. So m equals, and then it's change in y over change in x. So 6 minus 3.6 over the change in x values. That's the change in y, and then change in x at the bottom, which is 3.4 minus 2.2. 2.2. And that gives us 6 minus 3.6 is 2.4. 3.4 minus 2.2 is 1.2, and that simplifies to 2. So we've got m equals 2. And we said the m is the same as log b. So that means that log b then is equal to 2. Let's rewrite this in exponential form, so we can take the base, which is 10, raised to the power of the number on the other side, equals b. So we've got 100 equals b. Nice. Okay, so that's one thing solved. Now for a. So a is the c value. And so far, how do we find the c value in a straight line equation? Well, we substitute the points in, right? So this is the x and log y values, x and log y. So let's do this. Let's substitute it into this equation. So log y, which points do we use? Let's use the second point. So log y is 6. Then log a we don't know yet. X is 3.4. And then log b is log 100, right? So b is 100. So times log 100. Alright. So 6 equals log a plus, and log 100 is the same as 2. So 2 times 3.4 is 6.8. And then to get log a by itself, we can say take the 6.8 over. So 6 minus 6.8 is negative 0.8. That'll be equal to log a. And then we can again rewrite this in exponential form. So the base, which is 10, raised to the power of the number on the other side, equals a. Alright, let's see on a calculator, what does that give us? So 10 raised to the power of negative 0.8. Okay, so that gives us this thing. Let's copy that and paste. So that is what a is equal to. Okay, good. So we've found that a is, and round this off to 3 significant figures, so 1, 5, 8. The 4 will keep the 8 and 8. So 0.158. And b we found that was 100. Nicely done. Okay, for the second question, find x when y is 100. Okay, so we can choose if we want to substitute that back into this equation or into this one that we found here. That doesn't matter. I'm going to use the logs from the start. Okay, so we've got, I'm just going to write the equation down again. So log y equals log a. So log of 0.158, the log a, plus x log b. X log b. So b is 100. Nice. Okay, and then we want to find y, x when y is 900. So we've got log of 900 equals log 0.158 plus x times log 100. Log 100 is just 2. Okay, so we want to get x by itself, so let's take this over. So we've got log 900 minus log 0.158 equals 2x. So then we just divide by 2, and that'll give us x. So let's see what this gives us. Okay, so we've got log 900 minus log of 0.158, and that answer divided by 2 equals x. So we've got 1.877, that whole thing, Let me just copy this again and paste. Okay, so that is what x is equal to. And then again, we want to round off to 3 significant figures. So that'll be 1.88, because the 7 will turn that 7 into an 8. Good. How much do we have left? Okay, last question for this video. Solve this equation. Okay, I'm just going to rewrite this to start with. So we've got log with the base 7x plus 2 log with the base x, this time it is 7 there, equals 3. Okay, so the first problem we can see here immediately is the bases are not the same. So we need to make them the same. So I'm going to change this one into different base. So I'll keep the log base 7x plus, and then we're going to do 2 log 7 base 7 over log x base 7. Right, so that's just a change of base formula, equals 3. And now to get rid of the denominator here, of the fraction, we multiply everything by the denominator. So we've got log base 7x times log base 7x, so that's just log base 7x squared, plus, and then this will cancel out, so it's just 2 log 7 by 7, and log 7 by 7 is 1, so we can just write that as a 2, equals, and then 3 times log x base 7. Okay, so let's move everything to one side. So I'll keep the log base 7x, the whole thing squared, minus 3 log base 7x plus 2 equals 0. So again, we see this is a quadratic trinomial, so we need our 2 brackets. So the first bracket will have log base 7x, the second bracket will also have log base 7x, and to get to negative 3 we can do negative 2 and negative 1. And negative 2 times negative 1 gives us positive 2, and that's fine, that works out. Okay, so either, let's continue here. So either this part is 0 or this bracket is 0. So either log base 7x equals 1, if we take the 1 over, and rewrite that in exponential form, so we get 7 to the power 1 equals x, that just means 7 equals x. Or we can have log base 7x minus 2 equals 0. So that'll be log base 7x equals 2. Write that in exponential form, so 7 to the power 2 equals x, which means 49 equals x. Okay, now just to make sure, with logs we sometimes need to test this. So let's just test both of those and see if it works. So if we make x 7, then our equation, if we just rewrite this equation, so we've got log base 7 and then x is also 7, plus 2 log, now the base, which is x, is 7, and the other value is also 7, equals 3. Okay, log 7 by 7 is 1, plus 2, and log 7 by 7 is 1. So that works out to 1 plus 2, 3. So 3 equals 3, and that works. So this value works so far. So x is 7. Let's test the other one. So log base 7, and then x would be 49, plus 2 log, now the base would be 49, and 7 here, equals 3. So let's work out this part. I'm just going to do that on the calculator. So we'll have log 49 divided by log 7 plus 2 times log 7 divided by log 49. Oops, 49. And that also gives us 3. Fantastic. So 3 equals 3, so this one also works. So x equals 7 or x equals 49. Perfect. Okay, so that's it for question 10 and 11, and then we'll continue with question 12 shortly.